Good evening, guys. Welcome back. In the previous session, we discussed about Terraform concepts. What is Terraform? Why Terraform? How to install the Terraform architecture, and we are able to create our Terraform scripts. And we discussed about variables in the Terraform. And we discussed about input variables and output variables in the Terraform. Okay. And we also seen how to create EC2 instance by using Terraform, how to create S3 bucket by using Terraform, okay, and IAM user by using Terraform. And we also discussed about what is taint and tolerance, or what is taint and untaint in the Terraform, how to replace a resource by using Terraform. All those concepts we covered in the previous classes. And I have given one assignment also to create a VPC using Terraform. And in that VPC, we need to create one EC2 instance also. So how many of you completed that assignment? Could you please respond in the chat box? How many of you completed that assignment? VPC creation and EC2 instance creation by using Terraform. Come on. One person, Anu, completed. The remaining people? Only one person completed the assignment. Priyanka completed. Priyanka completed, Anu completed, two girls completed the given task. Okay, if anybody not tried, so please try that. It's very important to understand how to create VPC and how to create EC2 instance by using Terraform. If you try and if you are not able to do, then I will explain that. Okay, good, fine. Today, we are going to talk about one concept in the Terraform, that is Terraform modules concept. First of all, what is the meaning of module? First of all, what is the meaning of module? Module is nothing but set of configuration files we are keeping in one directory. So what is the meaning of a module? So Terraform module is nothing but set of configuration files that are available in one directory. So we have created several directories here, and if you go back in our previous classes, so we have created some Terraform projects. So go to this DevOps folder, in this Terraform scripts folder. So you can see here I have created 01 EC2. In that 01 EC2 some files available, and 02 EC2 some files available, 03 S3 some files available, 04 IAM some files are available. So any folder which contains set of configuration files, it is called as Terraform module. Are you guys clear with my point? What is the meaning of Terraform module? So module is nothing but set of configuration files that are available in the single directory. One module can contain one or more TF files. So if you take one folder as one module, in that folder, you can create one or more .tf files. For example, I have taken one project, 01 project directory. In that directory, I will create a file like provider.tf, and I will create a file main.tf, and I will create a file input.vars.tf, and I will create a file output.vars.tf. So like this, you can create multiple configuration files in one directory. The directory which contains multiple configuration files is called as one module. And here, one module can have any number of child modules also. That means in one folder, you can create several other folders also. In those folders, we can create our configuration files also. One module can have any number of child modules in the Terraform. So for example, I want to create one project. That project is IRCTC. In the IRCTC project, we are going to use EC2 service, EC2 machines I want to create for IRCTC, and I want to create S3 bucket for IRCTC. I want to create RDS instance for the IRCTC. Okay, IRCTC is one module that is called root module. Inside the IRCTC, EC2 is one submodule, S3 is one submodule, and RDS is one submodule. Inside the EC2 module, we are going to create main.tf, inputs.tf, outputs.tf. To create EC2 machine required for the IRCTC, we are creating 3 files. Similarly, S3 buckets we need to create for the project. Inside the S3, we are creating again main.tf, and we are creating inputs.tf, and we are creating outputs.tf. Okay, similarly for RDS also, we need to create main.tf, RDS bucket, RDS relational database I want to create for the project. For this also, main.tf, inputs.tf, outputs.tf will be available. So we are organizing our resources related configuration files using submodules in the Terraform. Along with this, the main files will be available for the IRCTC. Okay, those are our provider.tf is available. Our main root module is available. Main.tf is available, and outputs also available. Outputs.tf is also available. So this is IRCTC if you consider as one module. Inside the IRCTC, EC2 is one submodule, S3 is one submodule, RDS is one submodule. So like this, modules concept is available in the Terraform. Module is nothing but set of configuration files we are keeping in one directory. And in every module, you can keep multiple files, multiple TF files you can keep. And one module, we can have multiple, in one module, we can have multiple child modules also. So if you take one project called IRCTC application, for the IRCTC application, we want to set up infrastructure in the AWS. Instead of doing that setup manually, we will be using Terraform to set up that infrastructure in the AWS. EC2 machines I want to create, S3 buckets I want to create, RDS instances I want to create. For EC2 machines creation, configuration files in EC2 folder. For S3 buckets creation, configuration files in the S3 folder. Similarly for RDS also. And here, provider details in one file, these files in the root directory, and one main file will be available. This is root module file, and root module output variables will be available. So what is the benefit of doing like this? What is the advantage if you are creating like this? It will improve readability and reusability also. Okay, readability will be available, reusability will be available when we implement modules concept in the Terraform. So instead of keeping everything in one file, we are dividing them into modules. One root module, inside the root module, child modules also available. Are you guys able to understand what is the concept of Terraform module? What is the concept of Terraform modules? Come on, guys. Are you able to understand what is module and how we will organize the modules in the Terraform? One folder is called as one module. A folder can be called as a module. Okay. Now, so the submodules are available and main module is available. Root module is available. So Terraform commands we are going to run from the root module, and root module is going to invoke our child modules for the execution. We are going to create the root module files here. These 3 files will be available in the root module, IRCTC app. In the IRCTC app, these files are available. Provider TF, main TF, outputs available. So these are the root module files. Inside the root module, EC2 one child module. S3 is one child module. RDS is one child module. So whatever the Terraform commands are available, Terraform commands we are going to execute from root module only, and the root module is going to invoke the child modules for the execution. So root module is going to invoke the child modules for the execution. Are you able to follow me? Are you able to follow me? So what is the advantage of this modules concept? What is the advantage of this modules concept? Reusability. We are going to achieve reusability, and properly we are organizing configuration files of our resources. Instead of keeping everything in one file, we are organizing the configuration files here. Okay, good. Now let us understand how to set up a Terraform project with the modules. Terraform project setup by using modules concept. I want to set up one Terraform project by using modules. So I'm opening my IDE, guys, which is Visual Studio Code IDE that we are using from day one in order to set up the Terraform projects. Okay, let me use my command prompt only here, and yeah, so I'm going to create a project here. Okay, create a new folder. Inside the Terraform scripts, I'm going to create one folder. That folder name I'm keeping as Terraform modules. So this project name, which I created Terraform modules, that is called as root module. Okay, now inside this one, I'm going to create one subfolder. In that subfolder, I'm giving the name as modules. I created one subfolder. In that subfolder, I have given the name as modules. So inside the modules, I'm going to create new folder. The new folder name I'm going to create as EC2 module. I'm going to create EC2 module, and inside the modules, I'm going to create one more module with a name S3. Right. So Terraform modules available. In the Terraform modules project modules directory, in the modules directory, EC2 directory and the S3 directory is created. So here Terraform modules, root module, in that EC2 is one module, S3 is one module. Okay guys, now inside the EC2, I need to create some files. EC2 requires inputs.tf, input configurations, and EC2 requires main script, main.tf, and EC2 requires outputs.tf. Inputs, outputs, and main. Similarly, for S3 also, inputs.tf will be available, main TF file will be available, outputs.tf file also will be available. Okay, instead of keeping everything at one place, we are organizing them properly. Inside the Terraform, now you can go to this folder, Terraform scripts, Terraform modules. In the modules, EC2 configuration files. S3 configuration files are available here. I hope you got the clarity how we are creating a Terraform project with a modules concept. Come on guys, how we are creating the modules concept now. So what I have done to create this, create one project directory. First step we need to do, create a project directory. You can give any name for the project. So I have given some name as 05 Terraform modules project. Then inside that, create the modules directory. Create modules directory inside the project directory. So how it will look like? 05 TF modules available. Inside that we are creating one subfolder called modules folder. Now inside these modules nothing but resources. I'm creating two child modules. One is EC2, another one is S3. Then how the directory structure is going to look like? So it is 05 TF modules concept available. Inside that we have modules. Inside that we have EC2 and we are having S3. So this is the structure we have created now. This is the structure we have created. Now inside this create script files, create the script files inside EC2 directory and S3 directory. Create Terraform scripts inside EC2 directory. What files we have created? We created inputs.tf, we created main.tf, we created outputs.tf. Then in the same way, create Terraform scripts inside S3 directory. Same. Here also inputs.tf, main.tf and outputs.tf files we have created. So this is what we have done now. Creating a Terraform project by using modules concept. Without modules also you can complete this task, but everything you need to write in one file only. EC2 configuration, S3 configuration, everything you need to write in one file, which is not recommended. So that's why whatever the cloud resources that you want to create in the AWS, for every resource, we are creating a separate module. Okay, so I hope you got the clarity. What is the structure we prepared? We created a project, in that modules, in that EC2 and the S3. Inside the EC2, 3 files available. Inside the S3 also, 3 files are available. Are you clear with the setup now? Guys, are you clear with the setup now? Whatever the setup we have done as of now, are you guys clear with that? We just created the project structure, that's it. We just created the project structure, that's it. Okay, next root module. In the root module, I am going to create a file with a name called provider.tf. Which provider we want to use? In the root module, I'm creating provider.tf. Okay, and we can configure main tf file. And we can configure main.tf file. And if you want anything like variables you can configure. Variables.tf. If you want any outputs also you can configure. Now look at our directory structure. This is our directory structure. So inside the project directory, our project directory is called as root module of our Terraform. So inside this main TF, inputs, outputs, provider configuration is available. And for EC2, one module is available. EC2 files available in one directory. For S3, one module is available, S3 configuration in one directory. So we are organizing our files properly. Okay. Now good. First EC2. So let's go to EC2 directory, variables. What are the variables we want? For our EC2 instance setup. For EC2 instance setup, what are the variables we are going to take? Like our, when we talk about the variables, right? What is AMI that you are going to use? What is the AMI you are going to use? And what is the instance type that you are going to use? What is the key pair name you want to use? Those variables you can configure. Input variables available. These variables we are going to configure in the EC2 inputs.tf. AMI ID, instance type, and key pair name we are configuring in the variables. And coming to outputs. What are the outputs you want? I want a private IP of the EC2 and I want the public IP of the EC2. Private IP and public IP I want from this EC2. Then what about the main script here? The main script main.tf we are going to specify. Resource is AWS instance, VM2, variable AMI, variable instance type, variable key pair, default security groups we have taken. And virtual machine name I'm giving like this. So with this, EC2 configuration is ready. Inside the EC2 inputs TF, main TF, outputs TF is also available. Main TF is available, inputs TF is available, and outputs TF also available. In the same way for S3 also. In the same way we are going to do this for S3 also. For S3, what are the inputs you want? What are the outputs you want? And what is your main script for the S3? What is your main script for the S3? Okay. So in the main script and output variables, you can give any name for the variable, right? So variable name can be anything. Here I am giving the variable name as A_public IP. Here I am giving this name as B_public IP, private IP. Any name you can give for the variable. Public IP, A public IP, B private IP. Two output variables I have taken. My main script is available and my inputs.tf file is also available. This input file I am accessing in the main file. Similarly, go for S3. Here we have S3. S3 input variables, bucket name we are taking. In the S3 input, bucket name variable I configured, and in the S3 main script available, which is used to create the bucket, main script is available. S3 output variables available, take the output variable of S3. So I am giving variable name as C_S3 info. Okay. So EC2 files available in one folder, S3 files available in another folder. Now our modules configuration is ready. EC2 configuration is available in these three files. S3 configuration is available in these three files. Now let's work on root module. So in the root module, main TF, outputs, provider, variables. So let me configure my provider details here. Provider username, access key and secret key I am configuring. Provider is good. And variables. If you want to supply any variable from the root module, you can supply and it is optional. Coming to outputs, guys. What outputs we want? So every module is having its own output. A public IP, B private IP, these variables available. All the modules outputs I will access in the root module outputs. So when you execute Terraform with the modules concept now, EC2 is a child module, S3 is a child module. Child module are having output variables, A public IP, B private IP, S3, C info, S3 info. So there are three output variables available in the child modules. I will access them in the root modules output. Okay. How to declare that? Output Ashok IT VM public IP I want to access. Value. Where that public IP available? In a module. The public IP is available inside a module. So to access that, first we should have a module name. So in the root module main file, we need to access the child modules. So child modules I want to execute from the root module. So this is root module main.tf. So I want to call EC2 child module. I'm giving the name as my EC2 for the module. Where is the configuration available for this module? Source. In the source, okay, we should go inside the modules directly. In that EC2 folder is available. So I am calling child modules from the root module. In the root module main TF, In that I'm configuring EC2 module source. EC2 module configuration available here. Okay. And I want to call S3 module also, module S3, that is my S3. For this, where the configuration is available, inside the modules directory, S3 folder is available. In that S3 folder, S3 configuration is available. That means in the root module, we have main.tf. From the root module main.tf, we are calling the child modules. Now, whatever the child modules available, can we reuse these modules in the other projects also? I am working on 2 projects. I want EC2 in the 2 projects. Can I reuse one module in the another project also? Path. Yes, source you can specify where your configuration files are available. So that is called reusability. One project modules also we can use in the another module because EC2 instances required for multiple projects. So we will write EC2 configuration at one place and we can reuse that in multiple projects. S3 files we are writing at one place and we can reuse them in multiple projects. So we have created modules concept, root module, project directory is called root module. Inside that modules, EC2 configuration is one folder, S3 configuration is one folder. So EC2 is called one module, S3 is called another module. And root module main TF available. In the root module, I'm specifying EC2 is one module, that configuration available in this path. So Terraform will call child modules from the root module. It will go to this location, will execute EC2 files. Then it will go to S3, module S3, go to this location, load the S3 files, and it will execute them. Main TF. Provider TF is available, main TF available. Output. So EC2 output variables I will access by using this module name. In the EC2, already output variables available. Directly those output variables will not print now because they are in the child. So here, child module output variables we need to access in the root module output. Okay, in the root module, outputs TF available and modules are having the name my EC2. Okay, go to outputs.tf. First output variable, I want EC2 public IP. Where the EC2 public IP is available? It is EC2 module output. Okay, how to access it? Value is equal to, what is our module name? Module dot, what is the name of the module? My EC2 dot variable name. What is the variable name for that output variable in the EC2? A public IP is available. Okay, like this. Module name, module name dot child module output variable that we are accessing in the root module. Are you able to understand the link here? How we are earlier we worked with only one project, only one module available, directly output variables we configured, we accessed. But now we are using modules concept, root module, child modules. Child module outputs we need to access in the root module. Module dot module name. Where is the module name? In the main TF, module name is EC2. In the EC2, what is the output variable name? A underscore public IP. So here module dot module name dot child module output variable. Similarly, I want private IP. EC2 private IP. Module dot my EC2 dot, what is private IP variable name? B underscore private IP. module dot module name dot module output variable name we are accessing. And the next one, S3 output I want. I want output S3 bucket. Okay. So what is the variable name? Module dot module name I configured my S3 dot. In that S3, what is the output variable name? C underscore S3 info. Module dot module name dot module output variable name that we are accessing in the root module. So two child modules. First module is EC2. EC2 having two output variables. I'm accessing them. S3 is the second module, child module. S3 is having one output variable. I'm accessing that by using root module outputs. What is the benefit of this modules concept? What is the benefit of using this modules concept? Come on, guys. Maintainability, reusability, and readability. Organization. We are organizing the configuration files properly. Reusability. One module, one project module we can easily access in the another project also. No need to write the files again and again for every project. If you have the files in one project, if you want, you can reuse them. How to reuse them? You just need to specify where is EC2 configuration files available. You can give the path. Okay, so we are good with this modules setup. From where we need to execute the Terraform commands now? From where we need to execute our Terraform commands? From child module or from the root module? From where we need to execute the Terraform commands? Terraform commands we need to execute from root module, not from child modules. Which one is called as root module here? Guys, which one is called as a root module here? Project directory. Project directory is called as root module. Okay. Now go to our AWS account. Check it in the AWS. Any machine is running. We are checking in the AWS account. I got logged out. Okay, I logged in into my account. We can see the dashboard of EC2. Already in my EC2, two instances available, but they are not in the running state. Two instances available. One is VM1, Docker VM. And go to S3 also. See the buckets which are already available. Then we will understand whether our script is creating those resources or not. Go to S3 service in the AWS and see what buckets available in the S3. It is loading the buckets. You can check it here. Buckets. No buckets available. Two machines only running in the two machines only available. That too, they are in the stopped state. Currently, there are no buckets in the S3. Now, when I execute this project, EC2 machine should be created. S3 bucket also should be created. So I am executing root module now. Good. Let us first execute the command Terraform init. What is the purpose of this Terraform init command? Guys, come on. What is the purpose of Terraform init? Install the plugin. Initialize the script and install the provider plugins. Create the log file. It is initializing modules available. Initializing the modules EC2 and S3. Initializing the plugins related to the provider. Our provider is AWS. AWS plugins it is going to download. It is initializing. Yes, initialization completed successfully. You can see that log file got created. Provider version will be available. Next, I'm going for Terraform validate command. I want to see my script is correct or not. Yeah, success. The script is valid. You can do the format of your script. Terraform format. Indentation adjustments will happen with the format. And now if you want, you can execute plan command. Terraform plan command that is used to create execution plan for our resources. Okay, whatever the security tokens are available in the provider, those tokens are incorrect. It is saying in the provider access keys, secret keys available now. It is saying invalid. Let me regenerate the keys. I think I have deleted those keys for security. I will generate the keys again. Yeah, access keys are not available. Create the access key and the secret key. Okay, go here in the provider, update the access key and update the secret. Very good. Now let us go for Terraform plan. It is used to give the information what is the execution plan, what resources are going to create. So it is showing that argument is replicated something like this. Two resources to be added. One is EC2, another one is S3. So it is saying that boss, with this configuration, two resources are going to create and output variables available in every child module. All the child module outputs we are accessing in the root module outputs along with the module name. Now finally execute this Terraform apply command with the auto approve. So our script is going to execute. EC2 instance should be created. S3 bucket should be created and it should give me outputs. Bucket is creating and the machine is also creating. So child modules are getting called from the root module. Properly, we are organizing the script related to resources. EC2 is one resource, S3 is one resource. Instead of combining all the things in one file, we are segregating them. That concept is called modules concept. So you understand what is the modules and why we are going for modules. Yes, it is executed. You can see the output variables. Yes, private IP we got, public IP we got, S3 bucket data also we got. So child module outputs we are accessing in the root module outputs. Child modules output we are accessing in the root modules output. Yes, guys, good. I hope you got the clarity on how to work with modules in the Terraform. Is it clear? Good. So modules we are accessing from root module by using, we are giving a module name can be anything. So where that module configuration files available, we are giving that as a source. So that means it will go to this location. And here I said dot means current working directory. So here if you say dot in the modules, in the project root directory, current directory modules, in the modules EC2 3 files available. We are giving the path where the EC2 related configuration files available. In the current directory, go to modules, in that go to EC2, in that files are available. Similarly for S3 also, in the current directory of project root directory, go to modules, go to S3, here S3 files are available. The meaning of configuring this module here, go to that location, source location, and find the files and execute those files. So resources are reusable. Now in another project, I want S3. Then what I can do, if I want S3 in another project, guys, simply I will specify source project 05 Terraform modules in that S3. Do I need to write the S3 configuration files once again, or I can reuse them? One project modules can be accessed in the another project. Just we need to specify the path. That's it. Okay, good. Next concept is how to work with the environments in the Terraform, how to work with the workspace in the Terraform. Even if I start it now, I can't complete. It's a big topic. So tomorrow we are going to understand what is a workspace concept in the Terraform and how we are going to use those workspaces concept. Okay, good. Thank you guys.